So Fubini's theorem for triple integrals says if f, function of three variables, by the way, is continuous, I'm going to require f to be continuous we'll start with rectangular boxes, b equals a, b, c, d, r, s. By the way, just like in double integrals, this is on the x-axis, this part is on the y-axis, and this part is on the z-axis. So that's always the order when you see a box given to you like that. Then, what's up? How do you rewrite our generic integral as something useful? Here it is. So here's our triple integral over b, technically speaking defined as a limit as three things shoot off to infinity, kind of nasty. Well, you can write it as an iterated integral in the following way. So look, I wrote it as f of x, y, z, dx, dy, dz. X goes from a to b, y goes from c to d, and dz, z goes from r to s. Now, with double integrals, there were two possible orders. With triple integrals, pause the video and see if you can figure out how many possible orders there's going to be. Think back to your discrete days. With triple integrals, there are actually 6 possible orders. All right, and they all give the same value. And I will say, I should add here, when we're working over rectangular boxes. So this isn't true when we work over more general regions. You can't just randomly switch the order. But when you're working over a box and all of the bounds are constant, that's the key here. When all the bounds are constant, then it doesn't matter what order you pick. So you could go dy, dx, dz, dz, dx, dy, blah, 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 blah. There's 6 different orders. And I'll actually, a little bit later, work out a problem with you where we'll actually set up all 6 orders. For now, quite literally, as long as you keep whatever x goes, if x is the first one, then the x bounds go on the first integral, right? As long as you keep the bounds with the appropriate variable, it doesn't matter what order that you set up. So I thought we would work one out and set it up a couple of different ways. So let's do this example together. I'll set it up one way and then I'll ask you to set it up another way. So the example that we want to do is this triple integral over the region S of 3x squared y minus x y z cubed dv, where S is the rectangular box 1, 3 cross minus 1, 2 cross 0, 2. Now you can sketch that box if you want to, but I really don't need to. So the point is, using Fubini's theorem, I can rewrite our integral as the triple integral, and then I get to pick the order that I want. It doesn't matter what order that you're going to pick. I'm going to pick the order dx, dy, dz. So I'm going to write this down. Let's write our integrand down. I'm going to pick dx, dy, dz. I'd like you to pause the video in just a moment and go ahead and write the bounds in, what you think the bounds should be if we pick this order. All right, so x goes from 1 to 3, y goes from minus 1 to 2, and z goes from 0 to 2. Let's do one other order, just kind of as an aside here. So let's do the triple integral of the same thing, 3x squared y minus x y z cubed. Let's do dz, dy, dx. And again, pause the video, write down the bounds. Okay, so z goes from 0 to 2, y goes from minus 1 to 2, and x goes from 1 to 3. So that is another way that you could do this. And like we said, there's actually 6 possible orders. Now, the good news is this particular problem is really not that different or more difficult than just doing double integrals. This is just an iterated integral. First you integrate with respect to x, then with respect to y, then with respect to z. All of the different tricks that we had are the same. Maybe I'll work it out with you. I need to add another page. Where are we? We're right here. So let's see, add page. Oops, it went below. Oh man, my video time here is going to skyrocket because I can't get that to work. Well, we'll add one here. Okay, we got it. So let's go ahead and work this one out, at least a little bit. So I'm going to copy this and then paste it down here, and we'll keep going. Whoops. Okay, so for this problem, I'm going to first integrate with respect to x, and so I'm going to get 0 to 2 minus 1 to 2. The integral of 3x squared is just, think about it, just x cubed. And over 3, the 3's cancel, x cubed y minus x squared y z cubed. And then you want to evaluate this from x equals 1 to x equals 3 dy dz. And so you're going to get double integral. That's great, by the way. We're back to something familiar. Double integral, I get what 3 cubed is 27y minus 9yz cubed. Okay, then subtract, plug in 1, so minus y minus yz cubed. And we're going to go ahead and combine those, of course. And I'm going to have, what, 27 minus y is 26y. And then minus 9yz cubed plus a yz cubed is, what, minus 8yz cubed. And I'm not going to keep doing this. You can integrate with respect to y and then with respect to z. And when you're all said and done, you should get 54. So I'll ask you to work out the details and make sure that you get 54. Let's stop this video here, and then in the next video of this series, of this lecture, we will look at the 3 different types of triple integrals. We had type 1 and type 2 for double integrals. We're going to have type 1, type 2, and type 3 for